Hey everybody, I wanted to spend a little bit of time talking about types of reactions today. And there are 5 main types of reactions in chemistry that we're going to go over, at least for now. Okay, but before we begin, we have to do a little bit of defining things. And so we're going to define products and reactants. Okay, reactants and products. The arrow on a reaction separates the reactants from the products. And so this side of the reaction is the reactants. This side of the reaction is the products. Okay? And so the thing to keep in mind is that the arrow, the blunt side of the arrow, always is towards the reactants, and the head of the arrow always points towards the products. And so this is what we always start with in a reaction, and this is what we end up with. Now, also, up to this point, I haven't really said anything about this, but there are what we call diatomic elements, or elements that exist in nature, not alone, but together with themselves. So, and there's a list of them, and I pronounce this Hankelbrief, which means that if we have hydrogen in nature, it's not H, but rather it's H2. It's diatomic. Okay? Or if we have oxygen, if you remember in biology, we don't talk about oxygen as being O, but O2, or nitrogen is N2, on down the line. Chlorine, when we find it in nature, should be Cl2, and bromine, Br2, I2, F2. So it's Hankelbrief tells us what the diatomic elements are. There are 7 of them. The reaction for this video is the single replacement reaction. Okay, we're going to talk about the single replacement reaction, which is sometimes a reduction oxidation reaction or redox reaction. Is that type of reaction. And this is where we have an element and a compound form an element and a compound. And what happens here is one of the parts of the compound switches spots with the element, and the element switches spots and replaces the other one in the compound. So here we have zinc, and so what we're going to do is we're going to change zinc with the copper to make zinc chloride. Okay, and so it's a single replacement because only one thing is being replaced. The copper is being replaced and then ends up being all alone. And there are a lot of versions of this. It could be, instead of this, it could be the end. It could be Br2 plus CuCl2 reacts to form, and now this is diatomic, that's why I wrote that. Okay, reacts to form. Now Br2 doesn't replace a metal, the non-metal replaces the non-metal. So this forms, let's see, Cl2, the element replaces its respective element in the compound, plus CuBr2. Okay, and so it can replace, single replacement reaction can replace either half of the molecule. The other thing to keep in mind is that all rules for writing reactions or writing compounds apply. So if we have, up here I'll write, if we have a single replacement reaction where we're doing aluminum plus, let's say, AgCl, well, we get Ag alone because that's silver, but what we don't get AlCl, we get AlCl3 because aluminum forms a +3 charge, and so we have to do this. Then what we can do beyond that is balance the chemical reactions. But this gives us the reaction that happens. It gives us the kind of the skeleton reaction, so that way we can go on and do more with it. And so that's a single replacement reaction, and I hope you have a lot of fun with that.